So good morning everyone. In this video we are going to discuss about the observability. So observability of what is observability, Kalman observability, Gilbert observability, these things are going to discuss over here. Okay, here they are saying that a system is said to be completely observable if every state except T naught can be completely identified by measurement of the output y of t over a finite time interval t greater than or equal to t naught, assuming that the control signal u of t is also available. Okay, so here observability is related to the problem of determining the system states by measuring the output for finite length of time, and the concept of observability is the dual of to that controllability study of the possibility of control the state from the input, while the observability study the possibility of estimating the state from the output. Then the next step, the next significance, controllability and observability are defined under the assumption that the state equations are equivalent matrices A, B, C and D are known. The problem of observability is different from the problem of identification of the A, B, C and D from the information collected at the input-output terminals, and when the system is not completely observable means that few of its state variables are not practically measurable and shielded from the observation. So the state observability test the state space models is based on the two main method. One is the Kalman observability method, another one is the Gilbert test for observability method. Okay, in the Kalman observability, the method is applied from the matrix A whether A is canonical form of otherwise or form or otherwise. Gilbert observability is this method based on the transforming matrix A into the diagonal canonical form in case of distinct eigenvalues, or into the Jordan canonical form in case of repeated eigenvalues. After that, the test is used to determine the state of observability of the system. Okay, so like this way, this is going to use to find the observability of the particular system. Okay, so if I take down in this particular system, there are 4 resistance are there, all the ohms supplying 1 ohm each. So and also here one capacitor will be provided over here. Okay, so in this one depends upon the circuit. Actually the input is 0, so there is no matter what is the initial voltage across the capacitor. Yes, the output is identically 0 because the symmetry of the 4 resistor. Okay, so we know that input and the output both are identically 0, but we cannot determine the unequal in the initial state. Thus the network that describes the circuit is not observable. Okay, the state equation will say the circuit is not observable. Then the next is we are going to compare the two circuits. So in the both the A and B circuit, normally it have two variables. Okay, so one is the x1 through indicator and the voltage x2 across the capacitor. Okay, so this is the condition, two state variables, and the input current u is source. So if u is equal to 0, so input you are going to supply over here, the input is 0. Okay, then the circuit reduced shown in figure. Okay, so x is equal to 0, a not equal to 0, x2 is equal to 0, the output is identically 0. So matrix of a comma 0 dash and u of t is 0 yield the same output y of t is equal to 0 over here. Then comes into the Kalman's test of observability. In the Kalman's test of observability, find the observability of matrix Q0 in the size n, np into n according to the following equation. Q0 is equal to matrix of C, Ca power n minus 1 equal to Ct, At, Ct dot 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 At power of n minus 1 Ct, close the bracket. So find the rank of observability matrix Q0. the necessary sufficient conditions for the system to be completely observable is that the rank of observability matrix Q0 is n. So the Kaplans test of observability can be applied in any form matrix A, whether A is canonical form or otherwise. The observability of matrix Q0 is square matrix if system has single output only, while it will be rectangular matrix the size of np into n if the system has multiple outputs. If the system is not completely observable, then this test not give the information about the state variables and that are not practically measurable and are shielded from the observation. Okay. If Q0, the rectangular matrix of the size np into 1, okay, can be obtained the square matrix m is equal to Q0 into Q0 power t or m equal to Q0 power t or Q0. So both the things it will be invaried over here. So the Q0 and Q0 t it may be interchanged over here, and there is two possible cases. In square matrix m with n dimension and square matrix m with np dimension. That means these conditions should be taken place. M is equal to Q0 into Q0 power t. Okay, and always choose the case with minimum dimension. Usually observability test m is equal to Q0 power t and Q0. Okay, so here check the determinant matrix m is non-zero into the matrix Q0 as a rank n. Okay, so these are all the about the Kaplans test observability as well as in the significance. Okay, so that's it. So normally the observability is the the x of t naught can be completely identify the measurement of output y of t over a finite interval time like t greater than or equal to t naught. So assume that control signal u of t is also available. This is about the observability. Thank you.